Welcome everyone. So in this video I'll be going through the solution to question 326 from the list of sample exam P questions on the SOA website. The question reads, the monthly commission that an agent earns is modeled by a random variable x with probability density function f of x is equal to 1 over 20 e raised to the power of negative x over 20 for x greater than 0 and 0 otherwise. And we're asked to calculate the probability that the commission the agent earns in a month is within 0.5 standard deviations of x. Alright, so the first thing that we should observe in this problem is that x has an exponential distribution. So remember that for exponential distributions, the PDF is, so let's say that x is exponentially distributed. The PDF of x would be fx of x is equal to 1 over theta e raised to the power of negative x over theta, where the expected value of x is equal to theta. Alright, and looking at comparing the PDF of x that we have here, which is exponentially distributed, to this PDF, we should be able to see that they are very much identical. Alright, so therefore x is exponentially distributed, and the expected value of x over here, the expected value of x, which is theta, that is equal to 20. Alright, now what they're asking us to find, what they want us to calculate, is the probability that the commission the agent earns in a month is within 0.5 standard deviations of x. Now this is something that I want you to bear in mind, that for exponential distributions, the expected value of x is equivalent to the standard deviation of x. So therefore, we know that the expected value of x already, that is 20. Alright, so I'm going to equate all of that to 20. So therefore, standard deviation of x is 20. And they want us to calculate the probability that the commission the agent receives is within 0.5 standard deviations of the expected value of x. So the expected value of a distribution, it's really just the central value of that distribution. So I'm going to put the expected value of x in the middle, and we know that that is 20. And we want to find the probability that the commission the agent receives is within 0.5 standard deviations of the expected value. Alright, so 0.5 of the standard deviation, 0.5 of x, 0.5 of, I should say, 20, that's 10. So 0.5 of the standard deviation is 10. So one standard deviation above the mean, that is 20 plus 10, and that is 30. So I'm going to put that on this side. So I have 30 on that side, and one standard deviation, not one standard deviation, but rather 0.5 standard deviation below the mean, below the average value. That's simply 20 minus 10, and that is going to give me what? 10. And they want me to calculate the probability that the commission the agent receives is within 0.5 standard deviations of the expected value of x. So in other words, they want us to really just find the probability that x represents the amount, represents the commission that the agent receives, and that needs to be between 10 and 30. All right. So in order for me to do this, and remember that for exponential distribution, this is another thing that we should bear in mind that we need to remember. Fx of x, the cumulative probability up to an amount of x, that's equal to 1 minus e to the negative x, 1 minus e to the negative x over the. So for this case, I want to find the cumulative amount up to 30. So that is 1 minus e to the negative 30. Remember that the expected value is 20. Probability between of x between 10 and 30. I'm going to subtract from what I have here. I'm going to subtract the cumulative amount up to 10. All right, in order to be left with the probability of x between 10 and 30. So I'm going to have here 1 minus e to the negative 10 over the mean, which is 20. All right, and putting this in my TI 30XX multi-view calculator, my opinion, one of the very best calculators for this exam, I'm going to be left with a value of 0.3834005. That rounded to 2 decimal place is 0.38, which is of course my answer B. Alright, so that's my answer B, which is 0.38. B, yes, so that's B, not C. So it's 0.38, which is B. Alright, so if you have any questions, feel free to post them, and I'll try my very best to answer the questions. Alright, so until we meet again, take care.